Hello, welcome to my channel. My name is Loange, and in this video we're going to determine which is larger between e raised to the power of pi and pi raised to the power of e. Okay, so clearly you can't really say because this is e, which is about approximately 2.718, an irrational number, while this right here is approximately 3.142. So this is less than this. Okay, but when you switch the positions based on the exponentiations, you can't really say which one is larger. But if you use some calculator, you should be able to. So in this video we're going to determine which is larger without using a calculator. Okay, and we're going to do this analytically. And let me say the method we'll be using here is not really clear from the start, okay, because we'll be considering some function that doesn't relate with something like this. And the method, the way these kind of solutions come about is just most of the time is accidentally, where you just solve a problem and then you notice that the result could be useful and it's quite interesting anyway. So let's see what we will do. Well, the first thing I'll do is to consider this function. So we consider the function f of x equals to the natural logarithm of x. So you can look at the natural logarithm of x. Well, how does it relate with e to pi? Well, it may be because the e is the base of the natural logarithm, so maybe that's something to think of. Okay, so like I said, it should just be some result. Okay, so let's see what we can do. So first of all, I want to sketch the function, natural logarithm function. So that those are the axes I'm going to make use of. So let's just sketch the graph. So for the natural logarithm function, we'll have something like this. It doesn't touch the y-axis. As we approach 0 from the right, it goes like that. It touches the x-axis where the input is 1, that is that. Okay, so the next thing is, maybe let's consider e, because we need e and pi, right? We need e and pi. So let's consider e right here, and let's consider pi somewhere here. All right, great. So let me mark pi to the function. So when we say natural logarithm of e, that gives us 1 as an output. When we say natural logarithm of pi, of course that would just be natural logarithm of pi. We don't have a positive or an integer solution for that, so that's natural logarithm of pi. Okay, so what next? Well, the next thing I'll do is to consider these two things. So I'm going to consider the area of this rectangle, the rectangle from here to here. Okay, so let's consider this right here, and then let's complete the rectangle. Good. So I'm going to consider that rectangle. Well, the area of that rectangle, okay, clearly is going to be greater than the area under this curve. So you notice that if this is the area under that curve, all right, which I've shaded with blue, that's the area under this blue curve, that's the natural logarithm curve, is going to be less than the area of this rectangle, because this rectangle clearly has this space. So this, let me write that out. That clearly we know that the area, okay, under the curve, that's the natural logarithmic curve, okay, is less than the area of the rectangle. Good. So that being said, that means the area under the curve, which we will use the integral to denote that, that is the integral under the natural logarithmic curve, that is the natural logarithm of x, okay, or over the x variable where x ranges from e to pi. So you notice that that's from e to pi, okay, is clearly less than, that is the area under the curve, is clearly less than the area of the rectangle, where the length can be seen from natural logarithm of pi down to 0. So we'll say natural logarithm of pi minus 0. Sorry, let me write natural logarithm of pi. Okay, so natural logarithm of pi minus 0 will give us a length times the breadth of the rectangle, that is the horizontal length, will be pi minus e. Good, pi minus e. So that is the area of that rectangle, which is greater than the area under this curve. So the next thing we'll do is to evaluate this integral. Well, we can use the integration by part for that, which is quite easy. And to integrate natural logarithm function using integration by part, the result is just x times the natural logarithm of x minus 1. So this is how you can think about it. Write this place as 1, that is 1 times natural logarithm function, integrate the 1 and differentiate the natural logarithm. Okay, you should get this, and we're going to evaluate this from e to pi. Good. Okay, so this is less than what? The right hand side, we just have to expand this right hand side. This is pi times natural logarithm of pi minus e times the natural logarithm of pi. Okay, so the left hand side, let's substitute pi and substitute e. So we notice when we substitute e, which is the lower bound, what happens is that natural logarithm of e is 1. Okay, natural logarithm of e is 1. 1 minus 1 is 0, so this will be 0 when we substitute e. So let's just substitute pi and get on with it. That will be pi times natural logarithm of pi minus 1. Maybe let me distribute that at the same time. Okay, so that will be pi times natural logarithm of pi minus pi. That is when we multiply x with negative 1, we get negative x. When x is pi, that will be negative pi. Okay, so this is less than pi times the natural logarithm of pi minus e times the natural logarithm of pi. So you notice what happens next. This right here, we can delete these two, okay, because when we subtract, we'll get 0. Then we'll rearrange what we have and move this one to the left and then this one to the right to make the negatives become positive. That means we're going to have e times the natural logarithm of pi is strictly less than pi. Okay, the next thing I'll do is to use some logarithmic properties to put this as a power. That means we're going to have natural logarithm of pi raised to the power of e is less than pi. Alright, good. Okay, what next? Of course, well, I'm going to clear this natural logarithm using the inverse relationship that exists between the logarithm and the exponent. So if I make e the base of both sides, notice natural logarithm of something, okay, where e is the base, the result will just give us the identity, which is pi raised to the power of e. So from there we can deduce that on the left hand side, or the left part of the inequality, we're going to have pi raised to the power of e. This is less. Okay, so you notice why we are maintaining the order of inequality. This is less than e raised to the power of pi. Yeah, and this right here gives us the result between pi raised to the power of e and e raised to the power of pi. So this is what we get, that pi raised to the power of e is strictly less than e raised to the power of pi. So let me write that out. Pi raised to the power of e is less than e raised to the power of pi. Okay, like I said, this really doesn't really make sense for someone to think about. Okay, so that's why I said it's just a result of some observation that one can really see, oh, that means this is less than that. Anyway, it's a really fantastic tool and some very smart people can maybe get on with it, right? But yeah, there was an integral I did where I had to determine between 22/7 and pi, which is larger. Using an integral, the result helped me to determine that as well. I posted the video on my channel anyway. Alright, thanks for watching. I hope you enjoyed the video, and if you have different another method of getting this out, please don't forget to put it in the comment section below. I'll be very happy to learn from you. Okay, subscribe to my channel and we'll continue from my next video.